Morning students, in this lecture we will discuss about the efficiency of binary paper cycle and its representation on TS diagram. So in our previous lecture we have discussed about the binary paper cycle, what are the different advantages using mercury as the working fluid, disadvantages and schematic diagram of the binary paper cycle. So just reviewing it, we can see here. Here we are using a mercury boiler in this diagram. We can see this is the mercury boiler, and this mercury boiler generates the mercury. And this mercury generated here, this mercury is passing through the mercury turbine here. So it will produce the mercury work. Then exhaust of this mercury will pass through the mercury condenser cum steam generator, and the liquid mercury will be at the point C. Then with the help of this mercury pump, the mercury liquid will again supply to the boiler passing through this passage. And again in this boiler, this is the mercury boiler, it will generate the mercury steam, and the cycle is repeated here. So this is the mercury as a one working fluid. In the second working fluid, we are in the H2 or the water. You can see with the help of the boiler feed pump here, the water is passing through this mercury condenser cum steam generator. So here the rejected heat by the mercury condenser is received by the water. So water is converted here into the steam. Then this water is converted into steam. This steam will pass through this passage, and then it will reach here in this area, and this area is called as the mercury boiler cum steam superheater. So the steam which is passing through this steam superheater, steam will be superheated, and the superheated steam will pass through this pipeline, this pipe. This steam will enter the steam turbine, where it will expand and produce the steam turbine work. And exhaust steam from the steam turbine will be condensed, rejecting the heat in the steam condenser here. And now the steam will be converted to the water with the help of the condensate feed pump, and with the boiler feed pump. Again, it will pass through this mercury condenser. So this cycle is repeated. Now here in the TS diagram, we can represent both of these cycles. So, on the upper side, we can see this is the mercury cycle, and on the lower side, we are having the steam cycle. So, here we start from the point A. Point A indicates the entry of the mercury vapor in the mercury turbine. It will expand from point A to point B. This is the isentropic expansion shown by the vertical line. And after producing work, here it will produce the mercury turbine work, WT. What is the mercury turbine work? And from point B to point C, there will be the heat rejection which will take place. This is the QR. Heat rejection will take place here. C2D, it is, you can say, this is the operation of the mercury pump. Just I will write here, mercury means HG pump. Mercury pump is here. It will uh, pump increase the pressure, and D to this point A, it is the boiler operation. D to a boiler operation is the mercury boiler. Now, in the second cycle, which is the steam cycle, the point 1 indicates the superheated steam. The superheated steam expands along the process 1 to 2 in the steam turbine. So, it is producing the turbine work, which is the steam turbine work. At point 2, when the steam exhausted, so from 2 to point 3, there is a heat rejection. The heat rejection will take place here. 3 to 4 is the BF, we can also say BF, this is the boiler feed pump. Pressure is increased. And 4 to 5 is the heat addition up to the point 1. So these two cycles are combinedly shown here on the TS diagram. Now we can write how we have to get the efficiency. So if we have to get the efficiency, then as we know that efficiency of cycle, this can be written as W net by heat added, which is the QA. What is the W net? It is the net amount of the work done. So W net, because here the two turbines, mercury turbine and steam turbine. So we can write here the W T turbine work is for the mercury plus WT is for the steam. This is the total work W net. Also, we are having the pump work that we have to give in the cycle. So net work is written by decreasing or subtracting the pump work. So we will also write WP for the mercury and plus WP for the steam or the water. This will give us the net amount of the work done. What about the heat as it added? That is the QA. So heat added, this is the QA. Heat addition is being done in the mercury boiler. So it is HA minus HD in the mercury. HA minus HD. It is for the mercury. And for the superheating from point 4 to 1 or from 5 to 1 actually. So this is also H1 minus H5 for the steam. Okay. Now let us consider that mm is the mass of mercury supplied, mass of mercury supplied per kg of steam. Then we can write net amount of the work done. So W net will be equal to, first is for the mercury turbine work. The mercury turbine work is HE minus HB. So it is written as mm into HA minus HB plus for the steam turbine work, which is H1 minus H2, first part. Now we'll subtract the pump work, it is minus mercury pump, it is mm from C to D, HMM HD minus HC minus water pump work, this is H4 minus H3. Now, if we neglect the pump work, if we neglect homework, then we can write W net is equal to mm, this is the mass of mercury, Ha minus Hb plus H1 minus H2. That will be question number one. Now the heat supplied, which is the QA. This can be written as for the mercury it is mm. Here it is Ha minus Hd. Ha minus Hd. So we can also write HMD for the mercury. Plus heat are supplied in the superheated. So it is also H1 minus H5. H1 minus H5. Now we can write the expression for the efficiency. So efficiency binary vapor cycle, binary vapor cycle. Again, W net by heat supplied is QA. And directly the form bar. So this is MM HA minus HB plus H1 minus H2 whole upon heat supplied it is MM HK minus HMB plus H1. So this is the expression for efficiency of binary vapor cycle. In this way, we can find the efficiency of binary vapor cycle. Thank you.